MC4 solar connectors often get bad press linked to scenes like this. So my question for you is it the connector or the skill of the person making off the connector that is at fault? Poor quality connections in solar installations are a major cause of fires, so it's important for anyone installing solar PV systems to understand the critical role these connectors play. In this video, we'll try to unravel some of the myths and explore the reasons behind the fires and failures. What makes MC4 connectors problematic? These connectors operate in harsh conditions, handling high DC voltages and currents while enduring extreme temperatures, UV exposure, dust, rain and snow. We expect them to last for the lifespan of a solar module installation, often exceeding 20 years. However, issues such as high contact resistance, moisture ingress or mechanical failure can result in high energy arcs, posing a fire hazard, especially if flammable materials accumulate around poorly maintained solar setups. Many electricians new to solar installations may find themselves unfamiliar with the crimped connections utilized in MC4 connectors. These connections differ significantly from the standard ones typically used in conventional electrical work. They resemble the crimps found in electronics assembly and require a specialized crimping tool. In fact, most MC4 connectors are pre-wired to solar modules directly from the factory, which explains the choice of a connector designed for factory assembly rather than considering the practical needs of electricians in the field. Before we delve deeper, let's examine an original MC4 connector closely. MC4 connectors feature a plastic housing that encases metal connector pins known as open barrel crimp connectors. The first step in the assembly process is to attach the solar cable to the crimp connectors. Begin by stripping approximately 7 millimeters of insulation from the solar cable. Since solar cables are double insulated, you should remove both layers of insulation to the same length. We will start by assembling a female or positive connector. Insert the open barrel crimp into the crimping tool. This tool features a special locator to hold the crimp in the correct position, while a securing bar acts as a backstop, ensuring the stripped cable is at the required length within the crimp. The crimping dies are specifically designed to fit conductors of 4, 6 or 10 square millimeters. In this example, we will use a 6 millimeter squared conductor. Begin by positioning the crimp into the 6 millimeter die and partially close the tool, ensuring that the wings of the crimp align properly with the die. Then insert the stripped wire into the crimp until it reaches the backstop bar. When you close the jaw of the crimping tool, it folds the tabs of the barrel crimp using the die as a guide. This action compresses the cable strands, creating a strong mechanical and electrical connection. After crimping, lift the backstop bar